Now we've mixed up things a little bit more. On the left side of the scale, not only do we have these identical unknown masses with mass x, these three blue things, we also have some of the 1 kilogram masses over here. We actually have 2 of them. So now we're going to try to figure out what x is. But before we even do that, what I want you to think about is a mathematical equation that can represent what is going on right here, that equates what we have on the left hand here to what we have on the right side of the scale right over there. And I'll give you a few seconds to think about it. So let's think about what we have on the left side here. We have 3 masses with mass x. So you could say that we have 3x over here. We have 3 x's. And then we have 2 masses of 1 kilogram. So in total, we have 2 kilograms. So plus 2. So one way to think about it, the total mass on the left-hand side is 3x plus 2. 3 masses with mass x plus 2 kilograms. That's what we have on the left-hand side. Now let's think about what we have on the right-hand side. We just have to count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 blocks each have a mass of 1 kilogram. So the total mass right over here is going to be 14 kilograms. So we get, and we see that the scale is balanced. It's not tilting down or upwards. So the scale is balanced. So this mass, this total mass right over here, must be equal to this total mass. The scale is balanced. So we can write an equal sign. Maybe we'll do that in that white color. I don't like that brown. We can do it in that white color. Now, what I want you to think about, and you can think about it either through the symbols or think about it through the scale, is how would you go about, well, let's think about a few things. How would you first go about at least getting rid of these little 1 kilogram blocks over here? And I'll give you a second to think about that. Well, the simplest thing is, well, you could take these 1 kilogram blocks off of the left-hand side. But remember, if you just took these 1 kilogram blocks off the left-hand side and it was balanced before, now the left-hand side will be lighter and it'll move up. But we want to keep it balanced so that we can keep saying equal, that this mass is equal to that mass. So if we're going to remove 2 blocks from the left-hand side, we need to remove 2 blocks from the right-hand side. So we can remove 2 there. And then we can remove 2 right over there. And mathematically, what we're essentially doing is we're subtracting 2 kilograms from each side. So we're subtracting 2 from this side. So on the left-hand side, we now have 3x plus 2 minus 2. We're just left with 3x. We're just left with 3x. And on the right-hand side, we had 14, and we took away 2. Let me write this. We took away 2, so we're going to be left with 12. We're going to be left with 12 blocks. And you see that there. The ones that I haven't crossed out, there's 12 left. And here you only have 3 of those x blocks. And since we removed the exact same amount from both sides, our scale is still balanced. And our equation, 3x, is now equal to 12. And now this turns into a problem very similar to what we saw in the last video. So I will ask you, what can we do to isolate 1x, to only have 1x on the scale while keeping the scale, or 1x on the left-hand side of the scale, while keeping the scale balanced? So the easiest way to think about it is, if I want 1x on this left-hand side, that's 1/3 of the total x's here. So what if I were to essentially multiply the left-hand side by 1/3? But if I want to keep the scale balanced, I have to multiply the right-hand side by 1/3. And so if we can do that mathematically, so right over here, I can multiply the left-hand side by 1/3. But if I want to keep my scale balanced, I also have to keep the right-hand side. I have to multiply the right-hand side by 1/3. And multiplying it physically, that literally means just keeping 1/3 of what we had here originally. So we would get rid of 2 of these. And if we want to keep 1/3 of what we had here originally, there are 12 blocks left over after removing those first 2. So 1/3 of 12, we're only going to keep 4 boxes, 4 of these little 1 kilogram boxes left. So let me remove all but 4. So we're going to move those and remove those. I have left 1, 2, 3, 4 here. And so what you're left with, the only thing you have left is this x. This x, I'll shade it in to show this is the one that we actually have left. And then we have these boxes. We have these 1 kilogram boxes. And you see it mathematically right over here, 1/3 times 3x. Or you could have said 3x divided by 3. Either way, that gives us, you could say that these 3's cancel out. That'll give you just an x. And then on the right-hand side, 12 times 1/3, which is the same thing as 12 divided by 3, is equal to 4. And since we did the same thing to both sides, the scale is still balanced. And so you see that the mass of this thing must be the same thing as the mass of these 4 leftover blocks. X must be equal to 4 kilograms.
Let's try some slightly more complicated equations. Let's say we have 3 times x plus 5 plus 5. I want to make sure I get all the colors nice. Plus 5 is equal to 17. Is equal to 17. So what's different about this than what we saw in the last video is all of a sudden now we have this plus 5. If it was just 3x is equal to 17, you could divide both sides by 3 and you would get your answer. But now this 5 seems to mess things up a little bit. Now before we even solve it, let's think about what it's saying. Let's solve it kind of in a tangible way, and then we'll solve it using operations that hopefully will make sense after that. So 3 times x literally means, so let me write it over here. So we have 3 times x. So you literally have an x plus an x plus an x. That right there is a 3x. And then that's plus 5. And I'm actually going to write it out as 5 objects. So plus 1, 2, 3, 4, 5. This right here is 3x plus 5 is equal to 17. Is equal to 17. So let me write the equal sign. Is equal to 17. Now let me draw 17 objects here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, these two things are equal. So anything you do to this side, you'd have to do to that side. If we were to get rid of one object here, you'd want to get rid of one object there in order for the equality to still be true. Now, what can we do to both sides of this equation so we can get it in the form that we're used to, where we only have a 3x on the left-hand side, where we don't have this 5? Well, ideally, we would just get rid of these 5 objects here. You would literally get rid of these 5 objects. 1, 2, 3, 4, 5. But like I said, if the original thing was equal to the original thing on the right, if we get rid of 5 objects from the left-hand side, we have to get rid of 5 objects from the right-hand side. So we have to do it here too. 1, 2, 3, 4, 5. Now, what is a symbolic way of representing taking away 5 things? Well, you're subtracting 5 from both sides of this equation. So that's what we're doing here when we took away 5 from the left and from the right. So we're subtracting 5 from the left. That's what we did here. And we're also subtracting 5 from the right. Do that right over there. Now, what does the left-hand side of the equation now become? The left-hand side, you have 5 minus 5. These cancel out. You're just left with the 3x. You are just left with, it's a different shade of green. You are just left with the 3x. The 5 and the negative 5 canceled out. And you see that here. When you got rid of these 5 objects, we were just left with the 3x's. This right here is the 3x. And the whole reason why we subtracted 5 is because we wanted this 5 to go away. Now, what does the right-hand side of the equation look like? So it's 3x is going to be, let me write the equality sign right under it, is equal to, well, you could either just do it mathematically. Say, OK, 17 minus 5. 17 minus 5 is 12. Or you could just count over here. I had 17 things. I took away 5. I have 12 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That's what subtraction is. It's just taking away 5 things. So now we have it in a pretty straightforward form. 3x is equal to 12. All we have to do is divide both sides of this equation by 3. So we have so we're just left with an x on the left-hand side. So we divide by, let me pick a nicer color than that. Let me do this pink color. So you divide the left-hand side by 3, the right-hand side by 3. And remember what that's equivalent to. The left-hand side, none of this stuff exists anymore. So we should ignore it. None of this stuff exists anymore. In fact, let me clear it out just so that we don't even have to look at it. We subtracted it. So let me clear it. Let me clear it over here. Let me clear it over here. And so now we are dividing both sides by 3. Divide the left-hand side by 3. It's 1, 2, 3. So 3 groups, each of them have an x in it. And if you divide this right-hand side by 3, let's see, you have 1, 2, and 3. So it's 3 groups of 4. So when you do it mathematically here, the 3's cancel out. 3 times something divided by 3 is just the something. So you're left with x is equal to, and then 12 divided by 3 is 4. 12 divided by 3 is 4. You get x is equal to 4. And you get that exact same thing over here. When you divided 3x into groups of 3, each of the groups had an x in it. And when you divided 12 into groups of 3, each of the groups have a 4 in it. So x must be equal to 4. X is equal to 4. Let's do another one. And this time I won't draw it all out like this, but hopefully you'll see that the same type of processes are involved. Let's say I have, let me scroll down a little bit. Let's say I have 7x. So 7x, 7x. I'll do a slightly more complicated one this time. 7x minus 2 is equal to, let's say, is equal to, I'll make the numbers not work out nice and clean, is equal to negative 10. Now this all of a sudden becomes a lot more, you have a negative sign, we have a negative over here, but we're going to do the exact same thing. The first thing we want to do if we want to get the left-hand side simplified to just 7x is we want to get rid of this negative 2. And what can we add or subtract to both sides of the equation to get rid of this negative 2? Well, if we add 2 to the left-hand side, these two guys will cancel out. But remember, this is equal to that. If we want the equality to still hold, if we add 2 to the left-hand side, we also have to do it to the right-hand side. So what is the new left-hand side going to be equal to? So we have 7x. Negative 2 plus 2 is just 0. I could write plus 0. I could just write nothing there, and I'll just write nothing. So we get 7x is equal to, now what's negative 10 plus 2? And this is a little bit of review of adding and subtracting negative numbers. Remember, I'll draw the number line here for you. If I draw the number line, so if this is 0, this is 1, we could keep going in the positive direction. Negative 10 is out here. Negative 10, negative 9, negative 8, negative 7. There's a bunch of numbers here. Dot, dot, dot. I don't have space to draw them all, but we're starting at negative 10. And we're adding 2 to it. So we're moving in the positive direction on the number line. So we're going 1, 2. So it's negative 8. Don't get confused. Don't say, OK, 10 plus 2 is 12, so negative 10 plus 2 is negative 12. No. Negative 10 minus 2 would be negative 12, because you're going more negative. Here, we're having a negative number, but we're going to the right. We're going in the positive direction. So this is negative 8. So we have 7x is equal to negative 8. So now you might be saying, well, how do I do this type of a problem? I have a negative number here. You do it the exact same way. If we want to just have an x on the left-hand side, we have to divide the left-hand side by 7, so that the 7x divided by 7, just the 7's cancel out. You're left with x. So let's do that. If you divide by 7, those cancel out. But you can't just do it to the left-hand side. Anything you do to the left, you have to do to the right in order for the equality to still hold true. So let's divide the right by 7 as well. And we are left with just an x. Just an x is equal to negative 8 divided by 7. We could work it out. It'll be some type of a decimal if you were to use a calculator. Or you could just leave it in fraction form. Negative 8 divided by 7 is negative 8 sevenths. Negative 8 sevenths, or if you want to write it as a mixed number, x is equal to, 7 goes into 8 one time and has a remainder of 1. So it's negative 1 and 1/7. Either one would be acceptable. We have the equation negative 16 is equal to x over 4 plus 2. And we need to solve for x. So we really just need to isolate the x variable on one side of this equation. And the best way to do that is first to isolate this whole x over 4 term from all of the other terms. So in order to do that, let's get rid of this 2. And the best way to get rid of that 2 is to subtract it. But if we want to subtract it from the right-hand side, we also have to subtract it from the left-hand side, because this is an equation. If this is equal to that, anything we do to that, we also have to do to this. So let's subtract 2 from both sides. So you subtract 2 from the right, subtract 2 from the left, and we get, on the left-hand side, negative 16 minus 2 is negative 18. And then that is equal to x over 4. X over 4. And then we have positive 2 minus 2, which is just going to be 0. So we don't even have to write that. I could write just a plus 0, but I think that's a little unnecessary. And so we have negative 18 is equal to x over 4. And our whole goal here is to isolate the x, to solve for the x. And the best way we could do that, if we have x over 4 here, if we multiply that by 4, we're just going to have an x. So we can multiply that by 4. But once again, this is an equation. Anything you do to the right-hand side, you have to do to the left-hand side, and vice versa. So if we multiply the right-hand side by 4, we also have to multiply the left-hand side by 4. So we get 4 times negative 18 is equal to x over 4 times 4. The x over 4 times 4, that cancels out. You divide something by 4 and multiply by 4. You're just going to be left with nx. And on the other side, 4 times negative 18. Let's see, that's 40. Well, let's just write it out. So 18 times 4, if we were to multiply 18 times 4, 4 times 8 is 32. 4 times 1 is 4, plus 1 is 72. But this is negative 18 times 4, so it's negative 72. So x is equal to negative 72. And if we want to check it, we can just substitute it back into that original equation. So let's do that. Let's substitute this into the original equation. So the original equation was negative 16 is equal to, instead of writing x, I'm going to write negative 72, is equal to negative 72 over 4 plus 2. Let's see if this is actually true. So this right-hand side simplifies to negative 72 divided by 4. We already know that that is negative 18. So this is equal to negative 18 plus 2. This is what the equation becomes. And then the right-hand side, negative 18 plus 2, that's negative 16. So it all comes out true. This right-hand side, when x is equal to negative 72, does indeed equal negative 16.